Hello guys, welcome to the re-recording of the first class scalars, vectors and tensors of block 1 mathematics for CFD by Sky Guru. This lecture is presented by Dr. Aishwarya Kumar. I'm a PhD in mechanical engineering from City St. George's, University of London, and I work for Sky Guru. Sky Guru is a unit of Xberry, which is a registered MSME in Uttar Pradesh, India. So why do we need to understand the maths for CFD? We all know that CFD solves partial differential equations, for example Navier-Stokes equation, and in CFD the physics is expressed using scalars, vectors and tensors. Hence, understanding of fundamental knowledge of scalar, vectors and tensor is highly essential to understand the equations involved in CFD. So we will talk about what is scalar, vector and tensor. So scalar, vector and tensor, they all are tensors. Scalar is a rank 0 tensor. It has only magnitude. The best example is temperature. We can also say pressure and density. Vector is a rank 1 tensor. It has magnitude as well as direction. Example include velocity, or we can say force. So now tensor are rank 2 tensor. They describe how vector acts on different planes. Tensors have magnitude, direction and plane orientation, and tensors are represented as a matrix of component tau ij, where I is the direction of force component and j is the direction of the normal to the plane. As discussed in the previous lecture, tensors can be represented as matrix component. Here stress tensor, for example, are shown in Cartesian coordinates, where tau ij equal to tau xx, tau xy, tau xz, tau yx, tau yy, tau yz, tau zx, tau zy, tau zz, where tau xy is x direction force acting on the plane perpendicular to the y-axis. This is an example of a shear stress. And tau zz is z direction force acting on the plane perpendicular to the z-axis. This is an example of a normal stress. So on this slide we will try to further understand the tensors. So here I present an easy rule. Tau ij is the force in I direction on the jth face of the cube, where first index I represents the direction of the force and the second index j shows which face on which the force is acting. So tau xy is the x force acting on the yth face. In next slide we will present you an illustration to further explain you tensors. So let us use this slide to give you further explanation of tensor using shear stress. Here we have the general definition. Tau ij is a force component in ith direction acting on the plane whose normal is in jth direction. So here, for example, we have tau xy, where x force is acting on the plane whose normal lie in the y direction. So here we have tau xy and it's acting in the x direction, but the normal lies in the y direction, which is shown using ny here. So the interpretation is that x force acting on the plane whose normal lie in the y direction. The second index identifies the orientation of the plane y its normal vector. So let us try to solve some problems to visualize scalars, vectors and tensors. We will start with scalar first. The problem is that we will be modeling the temperature distribution on a linear rod, and that will be done using Python programming. So let us look at the illustration of the problems. So here is like we have a rod, and temperature at x is equal to 0 is equal to 300K, and temperature at x is equal to 1 is equal to 500K. And now temperature increases linearly as we have seen, so we can draw a line, straight line, somewhat like this. And this is how we expect the temperature to increase linearly. So what we will do is we will look at the equations which describes how it happens. So Tx is equal to 300 plus 200x, where at x is equal to 0 temperature is equal to 300K, and at x is equal to 1 temperature is equal to 500K, and temperature increases uniformly along the rod. So at each location the temperature has only magnitude, it has no direction, hence it's called scalar field. We already know. Now what we'll do, I'll write a Python program, and by which I will visualize this phenomena for you. So it's time to open VS Code now and create a new file and write it as Python file. We'll save it as problem 1. And now what we will do is we will try to import numpy and matplotlib. Here we will try to discretize the space between 0 and 1 using this line. And create 100 divisions in that space. If you want, I can print it for you and show it to you what it does. Let's run the program. So what it's doing, it's creating 100 divisions between 0 and 1. And now what we'll do, I will just comment out this line and write the line to describe the equation. And then we will start the plotting process using matplotlib. X versus t. X label would be positions on x-axis or position along the rod. Y label would be for temperature. In Kelvin, and we'll give it a title. And we'll call it scalar field. And let's hope it runs. So this is a line to show the plot. Let us hope the program runs. And we can see that we have successfully generated the scalar field using this program. The temperature at x is equal to 0 equal to 300K, and temperature at x is equal to 1 equal to 500K, and it increases linearly as expected. So the program is running fine. You can look at the program and copy it in your computer and try it out. For that, I'll give you some time. And it's time to start looking at vectors now. So now we will look at the next slide. So using this slide, we will try to describe the vector field on a two-dimensional plane. So we are considering a two-dimensional flow field. At every point x and y, the velocity has two components, vxy equal to u xy and vxy. In this example, we will try to model a rotating field. So we are assuming u equal to y and v equal to minus x, and the physical meaning will be shown once I write a program using Python. So let's minimize this and let's open VS Code, and let's try to create a new file, and let's say problem2.py, and we'll be using NumPy again. And then we'll be using map.lib again. Let's create 2D domain. So we are dividing the flow domain in x direction in 10 parts. Let's create the mesh. This is the command to create a mesh. Now let's visualize the mesh first. Then we will define the velocity. X label bx, y label would be y, and then we'll give it a title. This is to ensure that grid is equal in both x and y direction. Set aspect and would be equal. And let's see the grid. Let's try to run the program and see we have successfully generated the computation grid on which we'll be computing the velocity. So what I'll do is I will minimize this, I will cancel this, and then I will also comment out these lines. And what I'll do now is define the velocity component. U equal to y, v equal to minus x, and let's use matplotlib again to plot the two-dimensional vector field. We'll be using quiver plot, and we'll be using x comma y u v. Now it's time to give a label. Give it a title. We can give the title we want. And then what we'll do, we'll again ensure that grid looks equal in both x and y directions. So we will again set aspect here to be equal, and then we will use the show command to and see what we obtain. So this is the program, and let's try to run it, and let's hope we successfully generate the vector field. And we have successfully generated the figure. Here the vector field is rotational as we expected, and it is seen on the grid. So I'll be cancelling it, and I will let you see the program for a while. Then we will start modeling the tensor using Python. So hope you have seen it. I'll be minimizing it. But before starting the tensors, I want to look at this program again and also see the slide. So let's run this program again. It has got some issues. Let us see what is the problem. Let's click on this play button. Now I believe it is working. Yes. So let us look at what we got and let us see the slide. So I'm going to minimize the VS Code and just see the slide, and let us adjust it a little bit and see what we are the physical meanings. So as it says, at each point it has both magnitude and direction. So the larger arrows here shows the higher magnitude of velocity, and the direction is already shown with the direction of arrow. And arrow here, as the slide says, the arrow length represents the speed, or we can say the magnitude of the speed, and arrows represent the direction of the motion. So as written in the slides, we have generated the vector field using Python program, and unlike temperature, or we can say scalar, the velocity provides the directional information. So unlike scalar, the vector field provides directional information, which means both magnitude and direction. So I'll cancel this now. So let us start looking at tensor and how to model tensor in Python. So a tensor contains quantities acting in multiple direction: tau ij equal to tau xx, tau xy, tau xz, tau yx, tau yy, tau yz, tau zx, tau zy, tau zz. If I'll use a pencil, and from here I can tell you these are the normal stress, and the rest are shear stress. Let me do it again. Tau xx, tau yy, and tau zz are normal stress, and tau xy, tau xz, tau yz, tau yx, tau zx, and tau zy are shear stress. Now to represent the tensor in Python programming, we can simply do it using numpy and 2D array. So let's try to write a program. Let us minimize this. So let us open the VS Code now and create a new problem. File, new file, Python file, and then save it as problem3.py. And let's try to write a simple Python code. Import numpy as np and tau equal to np dot array, and it's a 2D array. And let's try to put values, or we can say the magnitude of normal and shear stress. So this is the first row. This is the second row, and this is the third row. 10, 15, 20. What we'll do is, let's try to print tau, and let's hope it runs successfully. So let's play the run button, and we have successfully printed the 3x3 matrix, which represents the shear stress. Let us do one more trick. Let us check the shape of the tau. And let us see what it does. Oh, I have made a mistake. I'll have to remove these brackets and then rerun the program. And it shows it is 3x3 matrix. So let us check the dimension of the array. What I will do is I'll comment out this line first, and then comment out this line, and I will use this command. And let us see. So it clearly shows it's a 2-dimensional array, which is also for the second order tensor, even though it's a 3x3 matrix. So hope you have understood so far. Let's go back to slides. So I would like to thank you for watching this tutorial. For technical assistance in mechanical design and simulation, please contact us using the email listed here, info@skyguru.in, or you can also contact us using our alternative email, indiaskyguru@gmail.com, or WhatsApp us on +91 983 9753. And if you like this tutorial, please like the video and support our channel. Thank you very much, and all the best.